Here we go. So this is GCE AS level maths question, right? So it's from Specimen Paper. Okay, I found this one, right? Now what they are asking to do here, that we have this graph. It shows the sketch of this curve. We have a straight line, and we have this equation. Okay, we have the coordinate p. So let me just write those coordinates. Okay, that's very important information. We have line L is a tangent. That's so crucial. Now we have given that the region R is shaded the boundary by the curve L, y-axis showed. Okay, blah, and show that the area of R is 24. Okay, so we have to find this area of R that should be 24. We are showing it. All right, so first thing is first. So our target here is just going to be the area of R. Now how we have to find the area of R? Well, you have to do the integration of it, right? Now if we need to do the integration, we need to have some limits, right? So let me just write it. So you have to do the integration. If we need to integration, we need to have limits, and when we need to have limits, we have to basically like drop lines, straight lines to define limits. All right, the upper and the limits are the upper one and the lower one. Got it? Now let me show here. So our lower limit is going to be 0 for sure, and the upper limit is going to be this if we drop a straight line. Now over here, now we have to do some bit of subtraction, bit of adjustments over here. So let me tell you very clearly. So this is upper limit, and this one is going to be a lower limit. All right, now an important distinction over here is this one. There's also a bit of triangle over here. Now whenever if we are going to do the integration over here, we will get the area of this one here, but we'll get the area of this one. All right, now if we get the area of this one only, you should notice that this is a triangle. So we can subtract the area of triangle to give this one, and this area. Now our area, but now there's a small triangle here. We have to also find the area of that. Okay, so now let's just begin. Let's just find the area under the curve by defining our limits. So now the upper limit is going, now let me just change my so the upper limit is going to be now 4. Okay, so this is the x coordinate, and the lower limit is going to be 0. All right, and we have to do this, the definite integration of this in respective to x. Now what you have to do, integration, add power to 1, adding power, and divide by new power, plus 11x and bracket, and we have 4 and 0. Okay, so let's just clean this up. Now over here you have to divide this. All right, divide this, add the powers. All right, this is just going to be 11x, alright, so if I simplify this, I'm going to have 2x to the power of 5 over 2 minus 9 over 2x to the power of 2 plus 11x. Now over here, let's just substitute the upper limit over here. And now let's just minus the lower limit, right, for the area of this part over here, this area, right? Okay, now the lower limit is going to be 0. So that's just basically 0 now. Let me simplify and let's see what. So now if I substitute this into the calculator, I have 36. Good. So now the thing is over here is we need to, in order to find this part over here, this part over here, I have to minus this area of triangle, right? Now we have to find the area of triangle. So how we are going to do that as well, that's also a bit tricky and you have to think. Now this one is very crucial information, that line L is a tangent. Now if it's a tangent to point P, that means that using differentiation we can find its gradient by doing dy over dx, alright, because it's a tangent to the curve, right? So we can find the differentiation, the gradient at this point, because dy over dx, difference in y and difference in x will give us gradient at point P when we substitute 4, right? Now why that is useful, now if we find the, let me explain you over here, if we find dy over dx, this will give us the m for L. So this will give us the gradient of L, alright? If we find dy over dx of y, right, of this y curve or curve C, let's just say, yeah, of curve C. Now if we find the dy of the curve, so that means that since this line L is a tangent, alright, we can use that to find the my is equal to mx plus c, right, is the equation of L. Yeah, now if you have the gradient over here, we can find, if we have the gradient, that means that we can easily find the equation of the line, because we have the point P, right? So that is required for grade to finding the straight line equation. And also since we have this point P, that will help us to find the this y-intercept. All right, now if we know the y-intercept, we'll get the whole equation, and if we get the whole equation, that means that we can find this over here, this x-intercept. So that means that we can do y is equal to 0. That's why we need to find the dy over dx of this equation, and it's quite tricky to recognize it. Right, and now over here, let me change my marker. So now dy over dx is now going to be 5 times by 3 over 2 is going to be 15 over 2x dropped to the power of 1 is going to be a half minus 9, right? Constant differentiates to 0, right? Now what we have to substitute, we have to substitute the x coordinate of p, because since we are finding gradient at p, so this is going to be, when I substitute this into my calculator, this is going to give us precisely 6. Right, now we are given the point P. Now point P is 415. Now if the point P is 415, what we are going to do now is we have to find the y is equal to mx plus c, since L is tangent. L is a tangent of curve C. Alright, and it has the gradient of 6, so that means that we can find the full equation of the line. Alright, so let's just substitute the gradient over here. Y is, and in order to, we have to find the whole equation of the line, so we have to find the y-intercept, the C, right? So now 6 times by 4, right? This is going to be 15 and this is going to be plus c. Now 6 times by 4 is 24 and 15 minus 24 is c. So 15 minus 24 is minus 9. So the full equation of the line is going to be 6x minus 9, right? Alright, now this is very important information that we need. Now if we have this equation, this full equation, that means that we have to find the y-intercept. Now how we can find the y-intercept over here, x-intercept, sorry, since this one over here is x-intercept, so we have to find this in order to find this area of triangle, right? So the x-intercept is now going to be when y is 0. So when y is 0, this is going to be now 9 over 6 is x. Now 9 over 6 is going to be 3 over 2, which is going to be 1.55 is equal to x, right? Now, yeah, so good sign that we find the x-intercept, yeah. So this is 1.5, right? Now this is 4 right over here. Now that means that we can find the base over here. All right, so the base is going to be so the base is now going to be 4 minus 1.5, yeah. So 4 minus 1.5 is going to give us 2.5. Now we need to find the height. The height is here, and as you know, the height is going to be this y coordinate, so that's going to be 15. So that is going to be 15. Now the area of triangle is going to be half times base times height is area of triangle. So now if I substitute 2.5 times by 15 over 2. What we are going to have is 75 over 4, which is going to be 18.75, right? Good. Now we can find the partial area of R. So we can minus the area under the curve. So curve area under the curve area minus area of triangle, right? Now the curve area, we found that was 36 minus 18.75. So 36 minus 18.75 is going to be 17.25. Alright, now we need the full area. Now remember, there is a still small triangle left over here. And also, for this small triangle, okay, I'm going to clean the things off over here. Sorry, okay. For this area, we need this base over here, little base over here, and we need this little height over here. Now, this little height, you should recognize this is the y-intercept of L. And now the base was basically the x-coordinate we found, x-intercept we found of L, x-intercept of L. Now x-intercept of L was 1.5, so 1.5 is our base. Our height is now going to be the y-intercept. So y-intercept of this x minus 9, this is going to be just minus 9. All right, now since we cannot take negative obviously over here, what I'm going to do is now take this as positive. All right, so so 9 times 1.5 times 2 is the small triangle area minus 1.5 over 2. This is going to give us 6.75. Now we need to add this area because it is part of the shaded area, this smally triangle. And now 17.25 plus this small area over here is going to give us the full area, and that is going to be 24. So here's our 10 marks. Quite a long question, but hope you try to understand something from this, and bosh.